O3b MEO is the most powerful satellite-based system ever, delivering multiple terabits through 30,000 flexible beams to over 400 million square kilometers. O3b MEO achieves 100% productivity, directing bandwidth to customers, not empty territory. Empowering exponentially more people and businesses with more opportunities. O3b MEO, unleashing the potential of an empowered world. O3b Power is the most powerful satellite-based system ever, delivering multiple terabits through 30,000 flexible beams to over 400 million square kilometres. O3b Power achieves 100% productivity, directing bandwidth to customers, not empty territory. Empowering exponentially more people and businesses with more opportunities. O3b Power, unleashing the potential of an empowered world. O3b MEO is the most powerful satellite-based system ever, delivering multiple terabits through 30,000 flexible beams to over 400 million square kilometers. O3b MEO achieves 100% productivity, directing bandwidth to customers, not empty territory. Empowering exponentially more people and businesses with more opportunities. O3b MEO, unleashing the potential of an empowered world.
Resources necessary to launch was checked. The 3-stage was filled with propellant and gases. In 2 hours, the launch vehicle's mass was multiplied by 10. The Fregat launch automatic sequence was activated at T0 minus 5 hours and 10 minutes, and the 3-stage at T0 minus 1 hour and 30 minutes.
So just to recap there, we have 2 synchronized sequences for Soyuz. The frigate upper stage was triggered 5 hours and 10 minutes ago, as he said, and that entered its final phase at just around about 10 minutes ago. And the One for the three-stage vehicle, the Soyuz, has entered its final phase now. It's called Klutschner Start. It was during that film at 5 minutes and 9 seconds. So that means that computers are running all the final operations at this point before the launch. And the teams who are overseeing those operations are here in the Soyuz Control Center, the Launch Control Center, as opposed to the Mission Control Center. So whereas mission controllers look at the whole mission, the launch controllers oversee everything to do with the launch itself. We have a number of teams working in here, and we have, of course, Russian and European teams working side by side, because, of course, Soyuz is a Russian launch vehicle. In Baikonur, the Launch Control Center is in several bunkers underground. And here, it's about a kilometer from the pad, in a specially protected building. That big grey mast that you can see there to the right of the launcher is the KZM, it's called. Inside it are all the feed lines, the umbilical lines connecting the vehicle and the upper stage, the satellites, to the teams on the ground. And those are being disconnected right now. This is the scheduled time. And a word about the ignition sequence. We throttle up the engines gradually. We switch the engines on 16 seconds before liftoff. We throttle them up gradually so that we can check that the engines are working correctly before pushing them to full thrust, which is, of course, when Soyuz leaves the pad. And when that happens, you'll see those four arms below. Can you see the blue arms? Can you see the yellow at the bottom of them? That yellow is a counterweight. Right now, the vehicle is suspended on those four arms. It's called a tulip. And at launch, they rotate away. Getting closer to the 1 minute mark, the range operations manager will call that out.
À tous EDDO, attention pour moins 1 minute. Top, à 0 moins 1 minute.
We are 1 minute to launch. We are orbiting the fourth batch of satellites in the O3b constellation, which Thales Alenia Space built for SES networks. And we're flying on board the 18th Soyuz to launch from the Guiana Space Center. Our best wishes now to all the teams as we watch the launch.
Largage du mât KZM. À tous EDDO, attention pour la séquence finale lanceur. Top, H0 moins 20 secondes. Largage du mât VKM. Allumage du tuyautage. Attention. Top, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage. Deuxième étage du lanceur. Les moteurs des premier et deuxième étage fonctionnent normalement. Bonne stabilisation du lanceur. Le vol est nominal.
Beautiful pictures there in the clear blue sky above the Guiana Space Center, over the Amazon rainforest. Soyuz blazing a trail. Range Operations Manager is telling us that everything is going according to plan, everything's nominal.
La propulsion du premier et deuxième étage est nominale.
The propulsion of the first stage is nominal. Our altitude, bottom left, 36 kilometers above Earth. Our speed coming up to 2 kilometers per second. And you can see the boosters being jettisoned. See how they twist and turn. All part of the plan. We have confirmation there of separation, and we saw them. We don't need them anymore. The boosters can fall away. We're shedding weight. We're burning the core stage now. The Block A burns for nearly 5 minutes. Picking up in speed there on the right-hand side and climbing into space. Right now we are 78 kilometers high and getting closer to what we call the Kármán line. That's the border with space. It's named after the Hungarian-American aerospace engineer Theodor von Kármán, who died in 1963. And it's where the air becomes so thin that we can no longer support vehicles with wings, and we have to use rocket science to stay up. Look at the front of the vehicle there. That's the fairing, the nose, and in there are the satellites. It's protecting them from the rigors of the launch. Notably the acoustic vibrations. You can just imagine how loud it is. Everything's going according to plan. And also friction, because as we fly through the dense part of the atmosphere, it causes the outside of the fairing to heat up. But as we get closer to the Kármán line, the air becomes so thin that we hardly have any friction and we don't need the fairing anymore. So this is the scheduled moment where we lose it. It gets jettisoned and we can see our satellites for the first time. Attached there on the front. And he's confirmed that the fairing has been jettisoned. Attached there at the front, the left-hand side. Some great images there from cameras on board a previous launch.
Le fonctionnement du moteur du bloc A est nominal.
He's telling us that the functioning of the Block A motor is going normally. So the 4 O3b spacecraft, lovingly built by the men and women at Thales Alenia Space, who are experts at this kind of thing. And if you look in the middle of the rocket, you can see a sort of latticework structure by the orange section. That is because Soyuz uses what's called a hot stage technique when it separates the stages, the second and third stage. The third stage engine switches on before the second stage switches off, and he's confirmed there that separation. So you can see our tracking stations here. Galileo, that's at the Guiana Space Center. And then Natal, that's on the northeastern coast of Brazil. Then we have Ascension in the middle of the Atlantic. And we're heading across the Atlantic. Takes a little bit of time for information to get from the launcher to us here at the CSG. Those stations send the information back here, but it has to go via Moscow first in order to be validated. So we're seeing all the key moments when they are scheduled to happen, but we get the actual confirmation from the Range Operations Manager just a little later. That's perfectly normal. Good view there of the 4 satellites attached to the dispenser, or the special adapter, which is that cone in the middle. A cone is the wrong word, a tube. And all 4 of them attached in an array, like petals from this angle. It takes Soyuz just under 2.5 hours to deliver the satellites from liftoff.
This mission will comprise several steps, the first of which being the 3-stage Soyuz flight. The action of the boosters, the second stage, and finally the third stage shall position the Fregat to an altitude of 200 kilometers after 9 minutes. Then, following 3 Fregat boosts, the spacecraft will be put into the separation orbit. The first pair will be separated after 2 hours and the second pair 20 minutes later. In parallel, Fregat will perform 2 other boosts in order to join its disposal orbit, where it will end its life. This mission will be visible from our ground tracking stations: Galileo in French Guiana, Natal in Brazil, Ascension in the middle of the Atlantic, Libreville in Gabon, Malindi in Kenya, and South Point in Hawaii.
So those are the tracking stations picking us up as we fly over, and we are scheduled to pick up the signal during that film there in Natal. That's the one in Brazil. You can see it there on the right-hand side. The tracking stations are often known as downrange stations or ground stations. The information that they pick up from the launcher tells us how the flight is progressing in real time, and it allows the experts to work out if things are going according to plan. And it also enables them to make an assessment after the flight and check how things went. It's called telemetry. It comes from the Greek. Tele, of course, means remote, and metron means measure. Everything's going normally. These computer-generated images are a simulation of what the experts have calculated is happening to the launcher and the satellites. The teams plan a very precise schedule of events, which is based on extremely accurate predictions for the flight, and they put all that information into the computer. These images are then a simulation of those predictions. So every movement and every position that you see is a simulation of exactly what's been planned for the flight. He's telling us that everything's going according to plan. You can see there, this is the scheduled moment for the 3rd stage to shut down its engine. We're really starting the next phase now of the journey. The upper stage is taking the wheel. It's called Fregat. And it's the intelligent part, the powered stage of the flight. Is over, and that's been confirmed. And Fregat has the rather more subtle job of delivering the satellites to a specific orbit and separating them. You can see on the top right is our trajectory. That's the planned trajectory, and the white cross is the actual position of the launch vehicle. Right now, Fregat's getting ready to switch its engine on for the first ignition. There it goes. This is the scheduled moment. It's going to burn for just